All right, I'm going to work this one out. I'm going to pick one of the formulas. I don't know. This is the one I'm going to go with. I don't know why. A is what? 4. Now I'm just going to replace my x in my function with 4 plus h, right? That's what this means. Replace that with 4 plus h. Rewrite the whole thing. So limit h goes to 0, 1 over square root 4 plus h. What's still there? No, plus 5. All right, so that's my 4 plus h into the function. Then I have minus f of 4. So minus, what's f of 4? 1/3. 1/3. All over h. Questions on that? What are you going to do with this? Okay, good. Conjugate is going to come in, but not yet. Common denominator first. Get these two together first. So this is where we come in and we introduce, what are we going to need over here to introduce the root of 4 plus h plus 5? Can I say 9 plus h? Is that okay with you? That's what that is, right? 9 plus h? And I can do root 9 plus h here also? Or I need to do that. And I also need something else. What do I need? A 3, right? This one has a 3, that one doesn't. So I need to put a 3 here and a 3 there. Is everyone with me? It's getting a common denominator between two fractions right now. So we have, this is equal to the limit as h goes to 0. Now when I put these two together, the numerators combine. So I have 3, right? 3 times 1, 3. Take away 1 times that. So it's 3 take away square root 9 plus h over the common denominator, 3 times root 9 plus h, all of that over h.
Wait, why did you just do 9 plus h? Because
The denominator is 3 root 9 plus h, right? That's what this denominator is? The common denominator? This is 9 plus h, right? 4 plus 5 plus h.
But if it was it looks like you did. You just cleaned it up. I know what you did. Okay.
Everyone else good? Now what? Now the conjugate. Now the conjugate. So I'm going to do the conjugate on top there. This right here times 3 plus, that's the conjugate, root 9 plus h, over 3 plus root 9 plus h. And we should get good things on top, right? The middle terms are going to cancel. What is the new numerator? 9. I don't know why I just wrote 3. Sorry. 9. That's your 3 times 3. The middle terms go away, and it's really just the last ones you have to worry about. So is that going to be positive or negative?
Negative.
Negative, and then whatever was inside the roots, right? 9 plus h, so we could put it in parentheses, 9 plus h like that. That's the new numerator. What about the denominator below that? What did I tell you about this thing? Leave it alone. Good. Do not touch that unless you want to get yourself into a mess, which we're already kind of in. Just leave that alone, and then all of that over h. And I'm actually going to write h as h over 1 this time, because I hate having fractions with 2 bars in it without, you know, like, I don't like that look. I like that look. It looks like a fraction over a fraction that way to me. All right, what does the numerator turn into? Close? Negative h, right? This is really just, up here, this whole thing is really just a negative h, right? That's what that is. 9 minus h. And then when I have a fraction divided by a fraction, I can flip this one up, can't I? And this would become times 1 over h. And I don't have to worry about this anymore. And do you see the h's will cancel? Yeah? So this cancels with this. But don't forget, we have a negative up there, right? So limit, h goes to 0, negative 1 on top, and then all this junk down here that I didn't want to touch, root, 3 times root of 9 plus h times, in parentheses, 3 plus root 9 plus h. There. Not yet. I need to do the limit now. I need to let h go to 0. Because I got the h to cancel, which was the whole goal. So let h go to 0. You get negative 1 on top. Let's see. 3 times, if that's 0, this is a 9. Root 9 is 3. So this is 3 times 3. Then parentheses, 3 plus what? Root 9, 3 plus 3. So 3 times 3 times 3 plus 3. So this is, order of operations, do this. This is 6, right? 6 times 9. So negative 1 over 54. Negative 1/54 is m. So the slope of our tangent line should be just slightly tilted, right? Just slightly tilted down. All right, what's the equation of the tangent line? So for the equation, I'm going to use this, y minus y1 equals m times x minus x1, right? That's what I'm going to use. What's y1? It was 1/3, right? So I have y take away 1/3 equals m, which I found to be negative 1 over 54. X minus x1 was 1, right? No, 4, wasn't it? Was it 4? It was 4. There's my equation. I'm going to solve that for y. Just out of, I'm just showing off that I know how to do it.
Are you always going to want us to solve for y?
You should always be comfortable solving for y and practice it. Practice it. Yeah, this should seem trivial now compared to everything else we've done. Any questions? I'm going to take it all the way because I want to be able to put it in into the graph and see if we've got it or not. Okay, distribute, and I get negative 1/54 x plus 4/54. And I can reduce that fraction, right? To 2/27. And we still need to add 1/3 to both sides. So y equals negative 1/54 x plus 2/27 plus 1/3. And I need a common denominator between these two. So 27?
Yeah.
9 on top, 9 on the bottom?
Yeah.
9/27. Put those together, 11/27. Wait, what?
Sorry, oh, wait, no, I see it.
Got it?
Yeah, that's it.
All right. Well, we'll know once I graph these. We'll know if we did it right. Okay, you got it? Everyone have the equation written down? I'm going to erase this, and then I'm going to put the graph up here. I'll leave it right there. All right, it's the moment of truth. The original function was, please remind me, was it 1 over? 1 over the square root of x plus 5. There it is. And the point that we were looking at was 4 1/3, which is that point. You see the red curve is the function. The red curve is the function. The blue dot is where we're looking. Hey, we got a negative slope, didn't we? Yeah, it's looking pretty promising right now. So let me put in the equation we got, which was negative 1/54 times x plus 11/27. Dead on. Got it? All right. I think I can do, I have plenty of time to do one more. How about this one? How about equation of the tangent line again, f of x equals x to the negative 4 at, 1, 1 is pretty boring.
2, 6.
You want to do 2? 2 and 1/16. There we go.
We do this with the other one.
Yeah, let's try this with the other one. You ready? All right. Well, first, can we all recognize that x to the negative 4 is 1 over x to the 4th? Yes? Let's start with that. Now, let's try the other formula. I'm going to have the limit as x approaches a, right? What's a? 2 of f of x minus f of a, right? So f of 2 all over x minus a, which is x minus 2. I'm going to replace f of x with one over x to the 4th, that's what it is, right? Minus f of 2 is going to be replaced with 1/16 all over x minus 2. Now what?
Is that like difference of squares on the top?
Yeah, you could look at that way, but it's also a complex fraction. You could maybe put them together first, right? Get a common denominator between those two, put them together. These two. So you need what, 16 top and bottom here? X to the 4th here and here? So you'd have limit x approaches to 16 minus x to the 4th over the common denominator 16 times x to the 4th all over x minus 2. I really am hoping that all of you can understand what I did there and can do that. Put those two together and get that. Got it? Okay, now the ultimate goal here is to get this x minus 2 to cancel. We want that gone, don't we? Because that's causing the division by 0. And I think there's been recognition already that this numerator up here does look like a difference of squares. 16 minus x to the 4th can be rewritten as, yeah, I could say, I'm going to do it the other way around because it should be 4 plus x squared 4 minus x squared. Right? That's,
It's the same thing.
well, no, because you said x squared plus 4, x squared minus 4. X squared minus 4 is not the same as 4 minus x squared. It would be the same here, but if you flip those two or change signs, it's not the same. Yes?
I'll look back on the last problem when we were supposed to work out.
Yes?
Do you have the answer?
For which problem?
The one you gave us.
Oh, no, I don't.
Man.
Well, I mean, even if I did, I'm not going to tell you until after class. I'll look at it. I mean, yes, I have the answer if I just remember what the problem was, but I don't remember what the problem was. So talk to me right after class. I'll just look at it real quick. Okay, this is that, right? Over 16x to the fourth over x minus 2. Still not there. There's another difference of squares. So do it again. Limit x approaches 2, 4 plus x squared, and then what? 2 minus x, 2 plus x, all over the common denominator, all over x minus 2. And it's almost there, right? This one and this one, almost. What do you need, though? You need to you need to factor -1 out. So I think because this is all clumped up together, I think I'm just going to factor -1 out of this one. And I'm going to save myself room. Watch this. Here it comes. -1's coming out. There it is, which changes that to a negative and this to a positive. Right? That's what happens. And now this is to take away x. That's what that is, which would cancel. But now there's a -1 here, so don't forget that. These cancel, right? Okay. If you don't understand that canceling, it's very important that you understand you could write it as a fraction. You could flip it. It would appear on the bottom right here, and then you do your canceling. All right, so good. I think that's it. We should have it. The bad part just went away. Limit x approaches 2 of, what do we have up top there? 4 plus x squared, 2 plus x over common denominator, 16x to the fourth. But we also have under that what? -1. So can I just put a negative out in front of everything? Yes, I can. Well, just remember a negative, look, if I just take that fraction, whatever it is, right? Dividing by -1 means just change the sign of it, right? So if I just slap a negative out front here, that has the same effect. All right, take your limit, see what happens. Let x go to 2. Okay, 2 squared 4, 4 plus 4 is 8, right? That's 8. 2 plus 2, that's 4. 8 times 4, we get -32 on top. And on the bottom, 2 times 2 times 2 times 2, 16. 16 squared?
128.
Nope. Just get your calculator out. 256, okay. No one sounded too sure of it. And that reduces, right?
Yeah, it's gonna be 1 over 8.
Okay, it reduces, who cares? That's a fraction, it's good enough, right?
I'm gonna remember that. Who cares? We're gonna write that on the test.
Yeah, who cares? All right, so then we could find the equation of tangent line, which would be y minus y1 here is 1/16 equals -32 over 256, and then x minus 2. That's your equation. Then you could distribute and do all your stuff, right? Solve for y.
Can we just put like 1 over 8 instead of that?
Yeah, absolutely. I'm checking. The point was 2 1/16. There's the point. Can you all see that okay? It's the red graph there. And what is, does anyone have solve for y or no? No, you can't just type it in right here. I have to do something else. I can do it, but I can do the implicit equation. Equals, hold on. Cannot understand. There it is. Okay. Do y'all see it? Y'all see the line? Does it look right? It does. There it is. Right there. Cutting through. Have y'all ever noticed that most computers and stuff always use like 2, 4, 8, 16, 32, 64.
Yeah, that's what I was telling about.
128.
iPhone anymore. Memory size, right?
Oh my gosh, what are we gonna do? Why are all these computer devices always, like a 64 gig iPhone? Why isn't it a 60 gig? Or why don't they do 70 gig? I always tell my classes about this. No, it has to do with the fact that computers only understand zeros and ones. So all computers are binary, right? It's either electrical signal is present or not present. So all computers on or off, right? And binary is a base 2 number system. We use base 10 to do our numbers. All of these numbers are powers of 2, right? 2, 2 squared, 2 cubed, so on and so forth. So all your memory and things like that are always going to be in powers of 2. Now, they have deviated from that a little bit. Like I think I bought the other day a solid state hard drive for my desktop at home, and I think it was a 500 gig solid state. So this has kind of been the way it's been done in the past, but some devices, they do deviate.
Like 1.5 terabytes?
Yeah, like 1.5 terabytes. It's not falling into this. I'm not quite sure why they're doing that. Maybe they're just going away from it a little bit, just like, okay, well, we could have an 80 gig hard drive. I think it's easier to go from, a 1.5 up to a 2, and then, from a 2 to a 3 and a 3 to a 4. If you start saying like, yeah, it is.
That's probably why.
Yeah, if you actually go in there and you look at the actual space, it's going to be a power of 2. They round. Okay, let's get back to this. What if I use the other formula on this one? H goes to 0. I would do f of a plus h, which would be f of 2 plus h minus f of 2 all over h. Right? That's what I would do? And that doesn't look very nice. Let me see. If I plug 2 plus h in there, I'm going to have to do 1 over 2 plus h to the 4th power minus 1/16. And that looks like a more challenging common denominator, but I think it would still go. I mean, this would still work. Do you see that? I mean, you could get a common denominator now. It would look like this. You could have 16 minus the 2 plus h to the 4th over the common denominator, 16 times 2 plus h to the 4th, all over h. That's what would happen if you put these two together. And then you're trying to get an h to cancel, right? So what I would do is 2 plus h to the 4th power. I would expand that out. That's what I would do. Who cares? Yeah, no, I could do it. I could do it. I'm just wondering if right now is a good time that I could cover Pascal's triangle right now. Because, yeah, we're not going to get into anything else today. There's no other material I want to show you. So, yeah, all right, we want to expand 2 plus h, right? We want to expand it. So I'm going to stop for a second, take a pause, and I'm going to introduce you to something. So we'll come back to that, all right? I'll leave it right there. So let's take a look at something real quick. What if I have a plus h? That's the thing that's always going to get plugged in when I'm doing that limit h goes to 0 formula, right? I'm always going to take that a plus h and plug it into the function. So I'm going to look at like different powers of a plus h. If I say take a plus h and raise it to the 0 power, what's the answer? 1. Everyone agree?
Yeah.
All right. So I'm going to put that 1 out here right in the middle. And just trust me, you'll see it in a minute why this is going to be the way it is. Then I have a plus h. What's a plus h to the first power? Just a plus h. I'm going to write it like this. A plus h. How many of you have seen this? Okay, I know in college algebra I show my classes. All right, now I'm going to do a plus h squared. So I trust that most of you feel comfortable doing a plus h times a plus h, and you do your little FOIL, right? And you got all that cute little thing. Then you would get 3 terms here. You get a squared plus 2ah plus h squared. That's what you would get. Do you believe me? Do you trust me on that? Yes? All right, now what if I say what's a plus h cubed? This would be a plus h times a plus h times a plus h. You multiply them, then it would be a mess, right? But it would be a cubed plus 3a squared h plus 3ah squared plus h cubed. You trust me? That's what it would be?
Yes.
Okay. If I do a plus h to the 4th, that's 4 times, right? That times itself 4 times. That would be a to the 4th plus 4a cubed h plus 6a squared h squared plus 4ah cubed plus h to the 4th. Yes, you can. All right, what's a plus h to the 5th? It's a to the 5th plus 5a to the 4th h plus 10a cubed h squared plus 10 again a squared h cubed plus 5a h to the 4th plus h to the 5th. I'm a genius, right? No, I'm not. There's a pattern, so let's see if you're picking up on it.
I mean, the A's just go up into power, right? And
The A's are what?
they go up in they just go up into power, like normal or whatever. So like the A raised.
Okay, so like let me pick this line right here. It's to the 3rd power. You're saying that the A starts out at 3rd,
Yeah.
and then it's 2nd power, 1st power, and then it's gone. Yes, I agree. That pattern's there. What else? The H's are the same, but backwards, right? The H's aren't there. 1h, h squared, h cubed. Do y'all see that pattern? Everyone see that pattern? The powers on A come down. Simultaneously, the powers on H come up. But what about all those numbers? That's the trickier part. So let me put one more down here. And I'm going to have you help me do this one. What am I going to have first? Just tell me about the powers. A to the 6th plus, I'm going to leave a space here for the number. A to the 5th, h plus a space for the number. A to the 4th, h squared, right? Power on A keeps coming down. A to the 3rd, h cubed. I'm going to run out of room over here. Space, what? A squared h to the fourth plus space a h to the fifth plus, what about that last one?
H to the 6th.
Just h to the sixth. Now it's just a matter of determining those numbers. All right? Everything I'm doing up here, right here, these are called binomial expansions. Binomial expansions. You take a binomial and you start expanding it, right? Binomial to the first, binomial squared, binomial cubed, binomial fourth. These are the expansions of binomials. So do you agree all I really need to do is determine what the numbers are? So the numbers are a little harder to see, but I'm going to highlight them right now. I'll use my red marker here. All right, this first number is 1, right? No, that's not, this red doesn't come out. This first number is a 1. And now let's just look at the coefficients. 1 and 1. 1, 2, 1. 1, 3, 3, 1. 1, 4, 6, 4, 1. Right? Y'all see them? Now what I'd like to do is, I don't want to erase that, but I'm going to. I'm going to draw those numbers out like this. 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. The way this works, this is called Pascal's triangle. And the way it works is that for each row, the n numbers, the two n's are always 1s. All right? The first row will have 1 number. The second row will have 2 numbers. The third row will have 3. The fourth will 4, 5, 5, 6, 6, right? And the way to determine the number in the middle is to add the 2 above it. So watch. This first row has 1 number, so it can only be a 1, because the n's have to have 1s. The second row has 2 numbers, but the n's have to be 1s. So this has to be 1, 1, right? The next row has 3 numbers. The 2 n's have to be 1s. The middle number is the sum of the previous 2 above it. 1 plus 1 is 2. Look at this row. 4 numbers. The 2 n's are 1s. This 3 comes from these 2 numbers. This 3 comes from these 2 numbers added. This 4 comes from the 1 and the 3. The 6 comes from the 3 and the 3. The 4 comes from the 1 and the 1. Or the 3 and the 1. Understand? No. No. So my next one was 1, and then I add these 2 together, get 5, right? Add these 2 together, get 10. Add these 2 together, get 10. Add these 2 together, get 5. And then I have the 1s on the edges. That's this row. So the next one will be 1, 6, 15, 20, 15, 6, and 1. So those are the numbers that go here. Now when I was doing it, what I was doing was I was doing, okay, I knew this was a 1, and I was just doing, okay, 1 and 5, right? Would have been 6. 5 and 10 would have been 15. 10 and 10 would have been 20. 10 and 5 would have been 15. 5 and 1 would have been, we're missing one here. Did I erase it? Okay, I erased it. This one would have been AH to the 5th, then plus H to the 6th, right? So this one would have been our, what, 6 here? And then the 1.
So that's for the coefficients, right?
Those are your coefficients. The exponents are the pattern you saw earlier.
Okay.
So let's see, could we do the next one? If we were trying to impress our friends, right? You're trying to show off, you're like, yeah. Now look, you have to know how to start, okay? So you gotta at least know, like, what, this one? You gotta know 1 so you can start breaking the tree down. So let's go, we're showing off, we're trying to impress our friends. A to the 7th plus 7a to the 6th h plus 21 a to the 5th h squared. Next one. 35 plus 35 Power's coming down on the a to the fourth. Power's coming up on the h cubed. Next one. 35 again. A to the third, h to the fourth. Next one. 21.
21.
A squared, h to the fifth. 7. H to the sixth. We're done. H to the seventh. There you go. Sorry that it's hard to see there, but that's it. Okay. Let's get back to the problem we were trying to solve. I have 5 minutes. We are going to, oh, you know what? While I'm here, no, I'll do it later. Just remember this. I'm going to refer back to this in a few sections after the test. Okay, after the test, we're going to come back to this. All right, so we were sitting at the limit as h went to 0 of 16, no, yes, 16, I believe, minus, 2 plus h to the fourth, no?
Yeah.
Over 16, 2 plus h to the fourth over h. I think that's where we were, right?
Yeah.
Okay. We were at that spot right there. And I wanted to expand 2 plus h to the fourth power, right? 2 plus h to the fourth power. This is a plus h, right? That's a plus h to the fourth power. So here's how I could do this quickly. 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, right? 1, 4, 6, 4, 1. This is my Pascal's triangle. This corresponds to the fourth power. Remember, this is the 0th power, first power, squared, cubed, right? This is the fourth power. I know my coefficients, right? I know my coefficients. This is a. Be careful with that. A is 2, right? A plus h. Okay, so what should this, I'm just going to write it down here. I have to come back up to this. What is 2 plus h to the fourth power? Well, it's 1 times what? A to the fourth power. What's a? 2. 2 to the fourth power? 16. Got it? That's basically a to the fourth power.
Yeah.
Okay. Plus 4 times a cubed, right? The power is going to come down on a. A cubed, which would be 8. But now the power on h comes up. H. Next one. Plus 6. Power on a comes down. So where are we?
4.
A squared.
Yep.
2 squared. 4. Power on h comes up. H squared. Where are we? Plus 4a. A is 2. Times the power on h comes up, h cubed. And then the last one, h to the fourth. To me, that's easier than multiplying it out by hand. But I'm also pretty comfortable with this, all right? So what do we have here? This is 16 plus 32h plus 24h squared plus 8h cubed plus h to the fourth. That's what that top right corner is going to become. And do you see what's going to happen?
Minus 16.
Yeah, the 16s are going to go away, and that's a good thing. So limit h goes to 0 of 16. Take away that whole thing, right? Take away, so you got to subtract each one of those. So minus 16 minus 32h minus 24h squared. You see what I'm doing? Just subtracting each of these. And then minus 8h cubed and minus h to the fourth. All over the common denominator, all over h. These 16s cancel. All those have an h in them. Factor out, cancel the h. You should get the same answer. Understand? I'm out of time, so I don't want to go any further. Make sure you do your homework. That's it. This is all we have for the week, right? So you have the whole weekend. Turn in that take-home quiz, right? Beginning of class next time. Watch your 2.2 video. Great. Let me turn off the camera real quick and then I'll talk with you.